perfect. Everything's fine. Yeah, so thanks for the nice introduction. As you already told, I'm like really into performance, and so is this talk. This talk will be about performance, and I hope everyone is really hyped now. I promise it will be a cool talk. I promise you will learn something new. Thanks, by the way, Stephen, for mentioning me. I will directly connect to what you have told us here, and I hope you're excited, as I am, about my talk. Cut my task into pieces. This is concurrent mode. All right. So let's dive into the topic. Do you know what actually happens when any user interacts with your web page? Like, this is the user interacting with your web page. Yeah, he's clicking. We see it's clicking. And the browser will then create a task for you to actually run whatever you wanted to run on that click event. So let's break those tasks a little bit down. Stephen already provided us a very nice overview about the performance panel, and we will use it also for this talk here. So if you break down this task, you see multiple stages happening here. So first of all, the big yellow thing on top is always the browser event. So there you see, for example, event click, because you've seen the user clicking. It could be any other macro task that ends up in your queue. And we also will talk a little bit about the event loop. So browser events always yellow. Then below of that, you see the bluish code, the bluish stuff here. It can get random colors. The colors just indicate from which file this function execution was coming from. And this is essentially your app running. It's getting executed at the moment. It can also be like browser extensions. So whatever ends up executing code at the moment, you will see here, as we were told by Stephen before. At the end, you see this purple and greenish stuff, and this is usually rendering and painting. And there are also like special tasks that are especially dangerous, and they are called long tasks. And they already look very dangerous because they are red. Red always indicates something bad happened. So let's take a look at what this red actually means. Like, this red area indicates how much your task exceeded the limit of 50 milliseconds. And then you have to consider, or you have to name your task a long task. This is what the Chrome browser does as a warning or as a hint for you, hey, there's maybe room for improvement here. And the tiny overflow here is considered the blocking time. So in this example, we have a click event listener that took 64 milliseconds to get executed, and our blocking time then is 14.9 milliseconds, because this is how we exceeded the threshold of 50 milliseconds. So, told you before, it's dangerous, and yeah, it looks scary, but why should you care at all? Because there's this wonderful new metric introduced this year in March, which replaced FID, and now it's INP, and this is like telling you how snappy your app is responding to users' inputs. And of course, you want to have this green, because otherwise you will lose users and you will lose actual money, and that's not what you want. So let's break down INP. INP is divided into 3 stages. You have the input delay, so the time it takes until you can actually execute the code you wanted to execute. Then you have, obviously, the processing time, so the time it took to actually process what you are doing. And then in the end, you have presentation delay, which would be then considered like the rendering and painting amount. It can also be an animation frame that's scheduled directly after the click, but usually presentation delay is rendering and painting. So let me quickly introduce myself. Hi, I'm Julian. I'm also, by the way, originally from Germany. I'm right now living in the beautiful city of Vienna. That's why also my favorite beer is from Austria. I am performance engineer at the beautiful company of Pushbase. I also recently got certified as NX expert. I'm trainer and consultant, and of course, RX Angular core maintainer. And this is very important for this talk because we want to discuss some things that we built for you that you can use to improve the performance of your apps. So let's take a look at how INP is calculated. So I brought a little demo application for you to take a look at. And this is my beautiful demo application. And by the way, this is a recent update landed in the performance panel here, where you can see all the local metrics directly measured without having to install this browser extension. But anyway, the browser extension is also running here. So this is why you can see all the Vitals logs here. So let me filter for Vitals. Let me kill all of this, and I will just do a normal native navigation. And we see The layout is not too complex, yet we have a red value here for INP. And INP here is broken down into all of the stages. We see INP 600 milliseconds. This is poor, of course, because our threshold would be 500 milliseconds, and everything that is below 200 milliseconds will be considered as good, and that should be our target in the end. So we see here all the 3 stages, and in this particular case, we see processing duration is taking up most of the time. So there we have actually room for improvement, because processing duration is the stuff that you have written, that it's your code, or my code in this case, that makes this perform bad. We can also break it down here in the performance panel and do a quick measurement to see how INP is displayed in the performance panel. So let's do a quick recording here. Go there, stop. And here we see our long task created. So this is why this is red, and we see a lot of red area here. So 500 milliseconds for the click event. And here you see in this interaction track, you see the pointer event. And also here, INP is broken down for you in the 3 stages. So you see input delay, processing duration, and presentation delay. And in our case, of course, as I mentioned before, processing duration in this case is our bottleneck. Okay. So what options do we have now? We have this long task. What can we do in order to improve that situation? Haha, we can be smart and we say, let's just improve INP. We schedule this huge amount of work into the future. Let the button maybe animate first, and then we have good INP, right? So how can we schedule stuff? We have different APIs. It's not an exhaustive list here. But for example, you can use setTimeout. You can use request idle callback. You can use the new post-task scheduler, which is only working in Chrome. Or there's something else that is called, for example, message channel, which is usually used in order to synchronize multiple tabs. But it's also a way in order to schedule some work into the future. So this is the picture that we had before. We had this extremely long processing duration because our click event listener had just to do a lot of stuff, so rendering all of our components at once. And the idea is, hey, we can make a beautiful, nice, fast INP value by just scheduling this huge amount of work into the future and let the click handler be like just tiny and empty. Let's take a look at how this is working. I need to be careful here that it's not falling down. So first, let's take a look at the code, what I did here. So this is our navigation, and this will be the button where I want to navigate, and it just has a method which is called nav2native_scheduled. So what we're doing here is we use a setTimeout to then call router.navigate, and everything should be fine. So let's take a look at what's happening here. Again, let me quickly refresh the page so that I have everything fresh and clean. So instead of going to native now, I will go to the route scheduled, and there you see interaction and INP 24 milliseconds. So this is a huge improvement, isn't it? So we can say, hey, it works. That's nice, job done. But there's always but. What happens if the user tries to interact with your page while this freaking long task is actually running? Well, you will have a lot of input delay because there's a blocking task on your main thread that is hindering the browser to immediately react to the next click event. And again, you will suffer and have a bad INP value. This is so not what you want. So let's discuss why this actually happens. We dive a little bit into the event loop now. So the JavaScript event loop essentially is an eternal ongoing while loop, which is iterating or waiting just for a queue to get new tasks. Then you can get the latest task and execute it, bit by bit. And this queue is the so-called macro task queue. So any macro task will end up in this queue, and then it will be just executed as they go. So what APIs cause macro tasks? Essentially all of the scheduling techniques: timer, idle callback, message channel, request animation frame. Any browser or DOM event, like XML request is getting you new data, click event, drags, resize, input, and essentially any event you know will end up as a macro task on the queue. And of course, then you have third parties that can also put work there. So the event loop works after the run to completion model. So what does it mean? let's take a look at this, this queue, what we have here. So we are starting here at event mouse down, so the user tries to click. First macro task we will have is event mouse down. What are we doing here? We execute two functions that are called work and work2. So the browser has to execute them before it can actually execute event click. So we execute a function on the click listener, which is called do something on click, and it has to process it as well. Then in the end, we have a timer fired, and now we see all of the tasks like horizontally over time. And the problem will be if we have a long task here and the user tries to interact again with your page, because we have the run to completion model, it has to complete its task that is currently executed, it cannot just stop it. So we again suffer and have bad INP with high input delay. And this is how you end up in this situation I've explained to you before. And of course, we can measure that. Let's measure it with the help of the DevTools. For this, I will turn on a little bit of throttling here. So let me clean this profile from before, and we want to start with a fresh new profile. I will turn on now CPU throttling, because then it's easier for me to navigate through the flame charts, and I have more time to click because I'm too slow probably to react within 500 milliseconds. So I will start the recording now, click on scheduled, and then I just click again somewhere randomly on the page. You didn't see the click, of course, but we can actually measure it. So this is what's happening. We have now this timer fired. As you remember, we used setTimer to schedule the task into the future. So this is our click event, yeah? Click event tiny, beautiful, nice INP in the beginning. But then, in the middle of this long task, we see here in our interaction pane, yet another interaction happened. And now we have INP of 1.7 seconds with a brutally long input delay of 1.6 seconds. And this is essentially what's happening. So let me turn off throttling again before I continue, because it burns my battery. OK, so now you are aware of the problem that we have. So what do we do with the long task then? Well, my good friend Kirill suggested to just play bricks with the flame charts. It's an amazing idea, actually. I would be very happy if this would be possible. Sadly, it's not. So we have serious stuff to do here. First thing that's always preferred is just reduce the work. OK, that's very easy to say. In certain cases, it's just not possible anymore because you have optimized everything that you could optimize, and you just are forced to render so many views at once. It's not like you can just ditch some of them and reduce the work like that. Then we have two other options. We can distribute the work, we can cut the task into pieces. And then, of course, some things will be more important than others, and then we also want to prioritize this thing that we distributed before. And this is where I need to introduce you to RX Angular Concurrent Mode, which we essentially stolen from the React framework and implemented it for Angular. So if you're interested to use it, just check out our library. And the concurrent mode is working with two concepts. First, we have distribution, and then we have prioritization. So let's talk about all the details about this stuff. First thing, scheduling, part of distribution. We know that already. We use setTimeout, for example, to schedule something into the future. We need that technique. Then we have chunking. What we want to do is to split our task into multiple pieces and then concatenate them together to be able to let the user, to let the browser again react to user input in the middle of this rendering process. So you can abort stuff, remove it from the queue, you can navigate away, and you should not run into the problem that you have high input delay anymore. So again, this example, the demo app has 4 components, right? A header, a sidebar, a content, and a footer. This is what we have in our app component, those 4 components. And in the flame chart, it will look like this. We have this click, then it renders the header, it renders the sidebar, the body, and the footer. And what we want to do is slice them on component level, so that we can render the header, then the sidebar, then the body, and then the footer. And in between, we can give the browser time to react again to user input. And you can do that quite simply with importing the RxLet directive and apply it just with an empty input in this case. It can also take state, and then you can forward data from an observable or a signal. In this case, it's enough. We only need the chunking. We don't need to pass data, so we just give it an empty input here. And this will just make sure to put all the work for each component into a queue and execute it bit by bit. We can also do this for lists, and list rendering in most scenarios can be brutally hard for your browser because you need to, for example, in a grid, render 500 rows at once. So yeah, list rendering can be a difficult problem, but there's not only ng4 or add4, there's also rx4, which is the big brother of rxlet. And you can use it just by replacing ng4 with rx4, and then you can slice each item into the queue and execute them one by one. Of course, it's not really dumb and slicing every item like individually, because this would produce a lot of overhead. No, you can configure a frame budget, also part of the distribution. So you can say, I'm only interested in having my application running in 30 FPS, which would result in tasks around 33 milliseconds. The default is 60 FPS, so you have per task 16 milliseconds to execute. So how's this implemented, or how is this working behind the scenes? Well, there's just a simple algorithm which just executes the work, measures its time, checks if it fits into our threshold that was configured, and in this case, hey, we have some time left, execute the next one, execute the next one, execute the next one. We are over the budget now, so we slice again here, give the browser time to render, and then execute the rest of the stuff. And again, like the event loop itself, it is like an endless ongoing while loop, which has just one condition to break out, and this is the threshold. So whenever we execute a task, we just measure its runtime and like, accumulate those values, compare it against the threshold. If we don't fit anymore, okay, we end the queue and start from the beginning. So let's take a look at how this is going. First of all, the component code. So I will go now to the concurrent component, where you can here see header bar rxlet, sidebar rxlet, main content rxlet, and footer bar rxlet. So this is all the changes I just did. And now I can go here to the concurrent pane, and you can see how it's like entering bit by bit into the view. And now I can do some fun thing and go here and navigate back in the middle of the process. Like there's no delay. There's actually no delay because we chunked our tasks. And we can also take a look how this is looking in the flame charts. So let's go here to concurrent. Stop the profile. And then we see all of the 4 pieces are chunked, and in between, like if we follow here the screenshots, we see header bars entering the screen, sidebars entering the screen, content is entering the screen with all the data, and then the footer in the end. So we should see here one task. The first one should be header work, sidebar work, then we have content work. Here we have ng4 actually doing its stuff and executing all the list items, and in the end we have the footer that's also rendered. So this is quite nice. Last thing I want to discuss here is the priority, because right now we have just rendered in the order we defined it in the template. Maybe that's not what you want, because in most cases the body is the most important thing instead of the header or the sidebar. So we want to change the priority and change the order of execution a little bit and not have it by default. So we want to render the body as first. So we need to switch priorities from the tasks and execute them in a different order. And we can do that by just passing a string, a named strategy. This is the input name. And we have immediate as the fastest, so the first priority, then user blocking, normal, low, and idle. By default, everything is just on normal priority, and then you can like configure your way around and then adjust the priority of your template. And you can do this, as I said, with the strategy input. So for example, if you want to have the body first, you just give it a strategy immediate. And the header gets the strategy low, and then the footer also gets strategy low. Let's take a look at how this is working. Okay. So I will just go now here. I can quickly turn on throttling again a little bit, because then the visual effect is a little bit nicer. So again, go now to concurrent prioritized. And you could see here how the body enters the view first, what you also can observe here is that the scroll bar is growing here, or shrinking. The scroll bar itself is shrinking, and the contents of the body are actually growing. And this is RX4 doing its stuff. So if we take a look at the code in the concurrent priority component, we have, first of all, the strategy set up here with low and immediate and user blocking. User blocking is used for rendering the list items. So you see RX4 is here attached instead of NG4, and it's just working the same. Just it's chunking up those list items and putting them into the queue. And we can also analyze this one. So let's do a recording of that as well. Start the profiler, go here, let it render, stop the profile. And now what we are seeing here is, first of all, first thing that gets executed is the actual content work here. And here, in this area, this one is RX4 doing its job. So RX4 here creates multiple tasks and tries to, and is actually working here, tries to fit everything into the frame budget. So that's why you see here task with 30 milliseconds, 14 milliseconds, 13 milliseconds, and so on and so forth, until the whole view is fully rendered. And you can also like follow it around here. You see all the views are entering. It's chunked, adding up everything. And then we continue with sidebar, header bar, and in the end, footer. Let me turn off throttling, go back to my slideshow. So to wrap it up, make sure to visit our open source library, give it a star on GitHub if you are interested in, and if you want to use it, we would be very happy about it. In case of you encounter any issues, just reach out to us. I want to give a shout out to my good friend Kirill again, who proposed already the Bricks game, but he also wrote a wonderful masterpiece which is called Mastering Interaction to Next Paint with RX Angular, which is going a little bit more in depth than my talk today. And again, I'm Julian Jandl. Thanks for listening to me. I just want to mention I'm working for the wonderful company of Pushbase. We are doing web performance consulting, of course, because that's where we excel at most. And it's just a really wonderful family which we are working with. So in case you're interested in performance improvements, reach out to us. And yeah, thanks for your attention. In case you are interested in the repository or the slides, here are QR codes you can scan and download it. And that's it for me.